All right. So today we're going to talk about linear functions. We started touching on it yesterday, but today we're going to kind of go a little bit more in depth. So remembering that we kind of use this flow to help us out, we have three key features that we talk about when we're dealing with linear functions. We talk about the x-intercept, the y-intercept, and then we talk about the slope. Okay. Now, there are 5 different ways in which we might see x-intercept, y-intercept, and slope. All right, we need to be able to identify it from slope-intercept form, which is all given in the notes up here. All right, this is slope-intercept form, standard form, and then point-slope form. So we're going to rewrite that here. That's y equals mx plus b, ax plus by equals c. And then point slope form is y minus y1 equals m times x minus x1. And then the graph, this is an example of a graph, what it looks like. And this is an example of a table and what it looks like. All right, so when we look up here, we see the examples, and then we're given in this table here, or in this graph rather, how to determine the x-intercept, y-intercept, and then the slope. All right, the slope of a line is always going to be determined on a graph by change over y over change over x. So rise over run, we say. So we start at this point and we're going to this point. So vertically we go up and then we go right. Now going up is going up in the positive direction. So this is a positive 6. And then this is going right in the positive direction. So this is a positive 3. So our slope, all right, and that may be a little hard to see. So our slope would be our rise, which is 6, over our run, which is 3, giving us a slope of this particular graph, which is 2, right? Now, if we look here, it says, hey, this is the x-intercept because it's the point where the graph crosses this x-axis. And then it says, oh, wait, this is the y-intercept because it is the point where the graph crosses this y-axis, right? And then we can identify the slope, x-intercept, and y-intercept in this table as well. All right, notice how the x-intercept is the value of x when y is 0, right? So this right here is the x-intercept. Right here is the y-intercept. And is the value of y when x is 0, y-intercept. All right, this is what it looks like visually over here as the x-intercept. Here's what it looks like tabularly or table-wise. All right, and then the y-intercept here, y-intercept here. And if we wanted to find the slope, then we just take 2 points and find the change in y over the change in x. Or you can use this formula right here. y2 minus y1 over x2 minus x1. All right, and do it that way. So when we came here, we did a little bit of this yesterday. In order to find the slope, we know we're going to look at our m. If we're looking at slope-intercept form. If we're looking at standard form, we need to look at negative a divided by b. For point-slope form, we're looking at the m, meaning the number in front of our parentheses. And then if we're doing it with a graph, we're going to just find 2 points. So here's a point and here's a point. And we're going to find the rise over run. If we look here at this table, it's pretty simple to see. We rose 1 and then we ran 2. So that's the slope there. All right, I'm going to try to get a different color for us. All right. And then with the slope, change in y here is 3. Change in x here is positive 2. So our slope here is 3 over 2. All right, we said we needed to just look at our m here. So then that's the number in front of our parentheses, giving us a slope here of 2. Our A in this situation is 3. Our B is 4. So when we look for the slope, we have to take the opposite of our A, so that's -3, and divide it by our B, which is 4. All right, and there we have it. Finally, our M in slope-intercept form is the number in front of our X. The number in front of our X here is 4. Notice that this is slope-intercept form, and therefore the slope is 4. All right. Now, when we're talking about the y-intercept, we said that's the point where the graph crosses this y-axis, right? So what we're going to do is come here looking at the graph. Where's the point cross the y-axis here? And it appears to happen about here at, or we can look here because this is the y-intercept column. So it appears to happen right here where y is -1. So our y-intercept, we say is 0, -1, right? Or you can just write -1, whichever one you prefer. Graphic table wise, we said that our y-intercept is 0, 6 in this example. So where is x0 in this example? X is 0 when y is 3. So that is our y-intercept. And then how do we do it when we're dealing with point slope form? All right, point slope form is the most complicated way because we basically need to put it in slope-intercept form, because in slope-intercept form it's clear to see that the y-intercept is right here, that number that stands alone, B. So when we come here, our y-intercept is 0, -8, or -8. All right, when we're dealing with standard form, actually, we're going to come back to standard form. Let's go back to point slope. So we need to turn point slope into slope-intercept by distributing the 2 inside, right? So that this becomes 2x plus 8. And then we have y minus 3. And then from here, we add 3 to each side. And what do we have? We get y is equal to 2x plus 11. So the y-intercept is right here, 11. With standard form, we're going to write our formula to find the y-intercept. We may not remember, so I'm going to write it here, c over b. All right, notice that our A we already said was 3. Our B we already said was 4. So C is -12. So then our y-intercept is C, which is -12, divided by our B, which is 4. So our y-intercept is -3. All right, and we did that by using this formula right here, okay? Now, finally, let's talk about the x-intercept. It is the point where the graph crosses the x-axis. Our x-axis graphically is here. So the point where the graph is crossing this point is right about here where x is 2. So we have 2, 0. Or we just say 2. So if we look here in this table, what appears to be the x-intercept? And it's right here where y is 0, -2, 0, or we just say -2. All right. Now, none of these are easy to find the x-intercept. We just have to make our y 0 and solve for x. So here, if we make our y 0, this becomes 0 equals 4x minus 8. We could definitely plug this in the calculator if we like. Or we can solve it algebraically. So add 8 to each side so that we have 8 equals 4x. Divide by 4 on each side, and x is actually equal to 2. All right, we're going to do the same thing here, right? We're going to make our y 0, so that's 4 times 0 equals negative 12, right? 4 times 0 is 0. 3x plus 0 is 3x, so this is 3x equals negative 12. Divide each side by 3, and x is equal to negative 4. Finally, we do the same thing here. We make our y 0. So 0 minus 3 equals 2. If we distribute, this is 2x plus 8, right? And we're going to go ahead and subtract 8 here. And this is negative 11 equals 2x. Divide each side by 2, and we have x is equal to negative 11 over 2. That's also negative 5.5. So we've come across all of these key features, and we know how to find them in slope-intercept form, standard form, point-slope form, graph, and in a table. Now we're going to work on our packet practice problems.